I'm just having another go at the wick holder because I want this O-ring to fit on it. I've only got a certain number of different O-ring sizes, and I want this to fit snugly but not too tight, because this will go in the cap that goes over it to seal the wick when it's not being used. So as you can see, I've taken off the 3-jaw chuck and I've put in a collet, and you can probably see that the collet will grip the workpiece right with very little amount of workpiece going into the collet, and it runs much more true and much more central, because you can probably tell that the collet is machined and is able to be machined because of its design to much more concentric design than the 3-jaw chuck, which effectively has a mechanism inside which is harder to get accurate than a collet like this. The disadvantage is you've got to pull different collets in for different diameters, and it's a bit more faff. So I've now got the wick holder with a little inside chamfer there, so that the wick can be pushed in easily, and a little shoulder there, so that's how far it'll stick up above the hexagon, and this will take it into the body with another little chamfer there. I'm reasonably happy with that. The O-ring sits on it tightly, but not too tightly. I think that's about right. Now, O-rings are a little bit technical. Obviously this is going to be inserted into the cap, this O-ring, and the rebate for it, the internal rebate inside the cap, is a little bit technical, because it needs to retain the O-ring when you push it down, but also it needs to allow the O-ring to squash out, as you can see in this diagram here. When the cap goes in, it's got to squash. So there are various requirements for O-rings. And what I'll also do is put these O-rings in some lighter fuel, not so much this one, but certainly the other one, to make sure that they're not sort of dissolved or made brittle or whatever by lighter fuel, because rubbers often are made brittle by various solvents and petrochemicals. So the reason I want to do the cap is that obviously the cap diameter will determine the minimum offset from between the flint and the wick, and so that's why I need to see if the cap will work correctly and give me enough not give me too much distance between the wick and the flint. So this is the R03 O-ring, which you remember is a nice snug fit on the wick holder, and this is the internal rebate it has to sit in, which needs to be 2.8 millimeters wide and 1.6 millimeters deep. That's a close-up, and the wick holder coming in here like this should have a 15-degree taper, so it's a little steep at the moment, but we'll see how we go with it. This is the O-ring in the center of the picture, and this is its diameter. It's 9 mm outside diameter, 5 mm inside diameter, and 2 mm ring diameter of the material. So this is how it'll look in section, with that slot, which we've seen is 1.6 deep and 2.8 long. And it turns out that that snug fit which I've machined in the collet turns out to be 5.86 millimeters, which is not surprising because it's a 5 millimeter internal diameter. So I need to make the entrance here 5.86 exactly, this hole 5.86 exactly, or perhaps 5.85. So I've used this tiny little boring bar, which is actually for internal thread cutting, I believe, but I've drilled this hole out to 5 millimeters, and then I've carefully crept in on it. Again, the collets, which I really like using the collets, they just feel so much more accurate. and I've internally bored out that hole so that you see it's really quite a good fit in there. And I've also made, I've just dropped it. I've made this tool. Where is it? There it is. Which you can see the top edge. There's the cutting edge. So there's clearance down the side in plan, and that'll cut this groove, which will be 1.6 mil deep. So there's enough depth there, and the width of the tool there is 2.8 wide. So that'll go up into, hopefully, where are we? That'll go up into this. Whoop, it'll be pushed up, or perhaps it'll be pushed across like this, and that will hopefully cut the correct groove on the inside of this hole. First time I've done this, making a tool for a specific internal bore cut, so we'll see how we go. After a bit of tweaking and laying it on its side and doing a little bit more shaping of it, the tool works more or less first time. It seems to have gone to the right depth of 1.6 millimeters, and you might just be able to see the O-ring in the end there, and perfect, nice tight fit, and that is exactly what I wanted. So now the trick will be to make this as thin as possible without encroaching on the groove on the inside, and then we can cut it off and perhaps knurl it or something and just see what we've got. And there's the finished cap with a bit of shiny end and some knurling, and you just see the O-ring inside, and it doesn't stand up higher than the flint wheel, which is good, so I think it'll kind of look okay, and it'll stop the wick sort of drying out or wicking up all the lighter fuel when it's in the case and perhaps damaging the case. So this is the final test rig. You can probably tell how many attempts I've had at this from the number of holes. Not all mine, but yeah. So it's the wick with the lighter fuel, and I don't set it all alight. Yay. And it turns out that this wheel here doesn't get too hot actually, and underneath here it doesn't get too hot, so there's no chance of the lighter fuel being ignited by the flame and the heat coming down through the wick. And at this spacing, I think there's just enough room to get the cap on there. Might have to increase the spacing by a very slight amount, but that's looking good for the mechanism. And I'm happy with the diameters. I think this one needs a 7mm hole. This one and the wick needs a 5mm hole. And as you've seen before, we've got the cap to fit over the wick. So I think we're ready to drill the hexagon. The two holes have been drilled in the top now. I think it was 7mm diameter for the piece you can see sticking through to the inside, and 5mm for the piece on the wick that you can see on the inside. This needs to be trimmed off in some way to become flush with the underside. This defect here on the corner will go when I turn it back down to the pen. You can see the recess in there is quite big. In fact, that only just misses the penny, which is good, I think. These holes were a little harder than I expected, because as the drill came through, it hits the the left hand side there it's cutting when the right hand side is free, and so it tends to move in the hole and not drill a circular hole. Similar on this side, so I do a bit of fettling there to get them to work, but I think that's all good now. And the cap fits on, it will fit on, because I've taken the spacing out of the experiment, and that needs to be straightened up and so on. Still a little bit more to be done with the thread inside this tube, so that the spring can be adjusted and the tension on the flint and therefore the sparks can be adjusted. And then there's another hole here for the filler cap, for the petrol filler cap, which needs to have its own O-ring to seal it. That'll go on there, plenty of space for that by the looks of it. So I'm pleased with that up until now. This is the O-ring that will go into the bottom, into this blank area here. You can probably just see, the shoulders inside the rebate. It's got to fit within that, so it's touch and go. It's almost as wide as that. I don't want to pick the smallest O-ring I've got, because otherwise the filling hole will be very small. So that's the O-ring. It's an R02 O-ring with these dimensions, and this is a sort of section through the case, how I expect it will look. I've got to work out how to make a brass screw with a thread all or most of the way up. The thickness here is not overly thick, so there's not a lot of room to work with. And the O-rings at the end there. So if we look at the slot in detail, the slot should be 1.6 deep and 2.8 wide. The slot is a function of the 2.0 dimension on the O-ring, and because this is the same as the R03, the larger O-ring that's going to be on the cap for the wick, this dimension, the slot is the same, because that was also 2mm diameter. So therefore I'm hoping I can just use the same cutting tool as before, only use it on the outside, which should be easier, rather than on the inside. And now I've just got to work out the order of sequence of lathe operations so that I can hold this and do the threading, do the rebating, and cut away from this diameter back down to this diameter. And the solid needs to be at least this diameter, of course. So that'll all be new learning for me, and probably have to try that a few times before I get it right. But we'll see how we go. And I'll also need to thread this inside with a tap. I've got a limited number of taps, so I'm not sure how that's going to work at the moment. So I've just had a more in-depth think about this. This is not how it actually is. This is more how it actually is. The thickness here is only about 3.3mm. And so I've had a look at these two schemes, a short sort of grub screw with O-ring, a standard O-ring, and a short screw with O-ring under the head. Now, given the O-ring's 2 mil, then if the O-ring's 2 mil and say the thickness of the head is say 0.5 mil, that's 2.5 mil. Leaves only 0.8 of a mil here for the threads, which is not enough. And this one is just as bad. The slot itself here wants to be 2.8. So this one, the slot's 2.8, gives you no dimension of thread here or here. So the way I see it at the moment is that this is just too thin, and I'm wondering if I can braze an extra piece of brass in here to thicken it up and give me a chance to get the filler to work. I found this bit of rod, which yeah, I think it's brass. Just doesn't quite fit in the hole, which is brilliant because I can turn it down and it will fit inside the internal hole. Then I can cut a chunk out of it so that it will thicken up locally. This position here where I want to, the blank position next to the hole at the bottom there, where I want to put in the filler arrangement. Obviously I still have to let through the two holes on the right that you're looking through there on the right. It has to let that past, but even so I think that's fine. Problem is now that when I solder all this together, I don't want this chunk soldered in, because when I try and solder the pennies and everything on, it'll come loose because it will melt as well. So I think I will try to silver solder this lump in place, because I think silver solder melts at a higher temperature than solder, so I've got a better chance of it staying in place during soldering. This is the piece now machined, and just fits snugly in the hole, and I'll cut out a suitable shape in here, and then we'll see if we can braze it in. Oh, silver solder it in place. Silver solder melts I think about 700 degrees C, whereas solder is about 300, so the silver solder shouldn't loosen when I solder the rest of the thing together. This is my big idea. This chunk now cut out of that circle to fit in there, to give me plenty of depth to get O-ring seals and things in there. I'll probably leave it that thickness at the moment. I'll machine it off at a later date if I want a bit of extra space inside there for fuel. I haven't shown the brazing process just because it's a lot of flame and it's hard to hold the camera at the same time, but the coppery colour there I think is perhaps part of the brass revert into copper under the temperature, losing its zinc or whatever, yeah, zinc. And on that side you can see the silver, which is a silver solder, and this hole needs to be drilled out because it moved a little bit, and also I need to just remachine the inside of the penny and level that top up and so on, which I can do after I've worked out how to actually do the filler hole. I've now got this as good as I can, but as you can see the maximum width inside is still only about 7mm, and so this 7.6 here is not going to work with this O-ring, this particular O-ring. So I've had a good look through my tap O-rings supply, and I found an even smaller O-ring which is only 6x3 like this, and then originally I thought maybe this would work. The hole only needs to be 5.4, so that could make that work, but I didn't think this was a very good design. I think this is better. So we've got the taper here which will help compress the O-ring as it goes in, and then you've got the countersink screw, and then all this is threaded, so there's no thread trying to come through the O-ring area, whereas here it'd be hard to thread up to there and then thread up to there and get both of those threads coordinated. They tend to come through this area, which I think wouldn't be good. So that then, with my added depth that I've got here, is I think the go. So that's perhaps what I'll do a practice before I start drilling holes in this. I'll do a practice so I can reuse this, which is the hard bit, but I'll be able to fix it in. This, of course, I'm not showing it here, but this side will be threaded as well. Again, that will be threaded only part the way through. Yeah, that's not good because I won't be able to thread it part the way through, and the thread up here won't be any good. So I'll probably have to move the O-ring right to this end. I'll have to move the O-ring down here so that I can thread all of this and then thread all of the hole. Yeah, design on the go. Hey. This is the little test piece I've done because I don't want to go drilling into the lighter proper and then find I've misunderstood something. So this is just a test piece, but this may end up being the final piece. So it goes in, and then there's a thread on the inside, but also that needs to fit reasonably tight, which it does, into the hole, because this is the bit that'll have the O-ring on. You'll see in a minute. This is the assembly with the O-ring on. It's looser than I had hoped, but anyway, we'll proceed. So here's the test piece. Needs to be 2.4 wide and 1.36
does put up some resistance,
so that it's the 1.36
it does feel quite nice actually.
Measured accurately,
and then I'll use this
feeler gauge
to blow air in, and if air comes out of here, I know it's not airtight.
Feeler gauges put together to make 2.4,
in fact, I've just done that, and it is airtight, so I'm pretty happy with that.
So that should be okay to accept the O-ring. Let's
drilling this main case here. This is now complete, apart from the head, which is still thicker than the final one, and this recess now is to the right depth, and I've sanded it and emeryed it smooth inside, so the O-ring's got a smooth surface to push against, and it seems to go in well. And there's a little bit of resistance there, which is good. And what I'll do now is I will cut a deep slot in this head, so that when I grind this flush, the slot will still be there, and it means then that I can retrieve this, unscrew it, which I can't at the moment if it was just flush without the screwdriver slot in. So yeah, all good. Next operation is to cut the screwdriver slot in the head. This is screwed into this brass. This is the brass test piece that you saw a while ago. This is screwed in tight to it with just the head protruding, and I'm going to use this slitting saw to come across and do a horizontal cut. I like to do it in this milling machine because I can touch off the slitting saw top and bottom of this, and then divide the reading up here by 2, and then it means I can saw right exactly through the middle of that head. And I'll go, the beauty of using this waste piece at the back is that I can go into the waste piece, so that the slot will be recessed into the lighter. Once it's fully screwed in, the slot will be below the surface of the outside surface of the lighter. So that's kind of what I'm aiming for. Here goes. Milling down the bolt head to get close to the body of the lighter, and then we get on the emery cloth to try and get it down flush. We'll have a look when this is finished. Let's go down reasonably close now. So upstanding a little bit, and you see the slot is deeper still, which is what I did with the slitting saw. That's why I went deeper. And I think we get on the emery board now and take that down flush. There it is. I'm pleased with that. I think the next operation will be to go around the edges of the hex before I start putting stuff on, and just
do a chamfer around the perimeter. It will have to be taken back. Does that rebate for the pennies too deep? But I think it would be a good time now just to have a look at the perimeter.